I would like to ask you a
Yeah.
little technical question here. With the gas boiler, you've got the modulation, and some of them modulate better than others. But basically, you know, according if you've got weather compensation or whatever you've got, your boiler is going up and down, putting in more, rather like an accelerator on a car.
Yes, exactly.
You need more gas when you need more gas, right? So, how does a heat pump modulate? In other words, when you've got that weather compensation and it's adjusting the flow temperature, is it simply switching the compressor on and off, or is it slowing the compressor down?
They for years were on and off, and they've within the last 5 years, inverter-based compressors have come onto the market, which modulate the speed of the compressor, and they modulate down to round about between a half and a third of what their maximum output is, so nowhere near as much as gas boilers anymore.
But some gas boilers aren't that good at modulating.
No,
actually.
but they were getting better. And now it looks like they're getting pushed out anyway. And so they do modulate now. Once you get down to that kind of modulation, it kind of matters less anyway if it's sized correctly. It may cycle, say once every half an hour, but the flow temperature is so low that your losses are tiny. Your efficiency losses are tiny, if that makes sense.
So based on that, what I'm wondering is why can't you, right, if you don't know, like you've got a house that's a little bit difficult to assess the heat loss on, why don't you just put in a 12 kilowatt heat pump and let it modulate? Where's the penalty?
That's exactly what we're going to do. So the heat pump that we're going to specify for this is 12 kilowatts. This is where it gets a bit complicated. At -7 outside.
Oh, okay. So your design temperature is -2.
Exactly. So actually, the heat output of our heat pump or your heat pump is about 13.4 kilowatts. So it's going to be slightly oversized, if anything, and that should modulate down to round about sort of 4 kilowatts output minimum. On sort of mild days, and then it will just sort of trickle in heat as and when it needs to.
We like margin for error.
Yeah. Well,
absolutely.
You're obviously going to be less brave than. I mean, the other thing you can do. So if this was the other way and it was more heat loss and it was slightly on the underside, so that's the largest heat pump really you can get. I would have suggested a backup immersion like older heat pumps used to have in case they couldn't quite reach it. If you're only using that for 6 hours a year, the effect on your efficiency is 0.0 something percent, tiny. So there's a kind of get out that gives you backup if you need it, and especially if you get icing up and stuff like that.
So what the backup could be, you could get a fan heater in for very cold weather.
You could do,
You know, because when you're talking about backup immersion, you're talking about direct electricity, so there's no different to that plugging it into the wall and warming up the room you're in.
Correct.
For a few hours if it's -7 or
That's
below.
correct. If I'd left a property with that in as the solution, though, I don't think I've done my job very well. You're right in what you're saying. You're right
because if I'm talking to a customer, I'm saying, right, we're on the cusp here, okay? So what we're going to do, we're going to stick you in a 12 kilowatt heat pump, which will do the job for 95% of the year. For that little bit where it gets extra cold, and we don't know, obviously the weather's unpredictable. For that little bit, you've got an option of either putting in another heat pump, i.e. two heat pumps, or you're saving money on that and you accept the fact that every so often you're going to have to stick on a fan heater.
You're 100% correct.
Or what I've got, absolutely marvellous now in my house, we've all got them now, the old electric throw.
Here's a bit more detail on that. If your heat pump is only sized to down to 0 degrees instead of -2, when it does get down to -2, your room temperature will only drop by 2 degrees. It won't drop more than that. So the exact differential will drop by. So if you had it at 21, you might be at 19. You're not going to be freezing to death. And actually, you're saving energy anyway during the coldest part of the year. So it's not actually that bad. MCS rules are, though, whatever we install has to cope down to -2. So we can't, if we want to comply with MCS,
-2, fine, -2. But you were talking about -7 there.
So if you're going to, if it's going, so they're sized at -7 because they're designed in Germany or whatever.
I think the other side of things, though, consumers will always remember those hours.
Oh, absolutely.
But the theory is right.
Give them a free jumper.
Exactly.
Heat Geeks.
You're going to have plenty of capacity in here, and your radiators have plenty of capacity because they're all ginormous. So there's no worries about this job for me, which means we should be in and out fairly snappily because normally we're having to swap radiators.
Don't predict Don't predict.
I've
never do that.
I'm confident.
The number of times I've been in the house said, "Oh, it's a quick job. It'll only take 5 minutes." 2 days later, I'm still in there because of some nightmare.
I'm known for good predictions, so let's see how that goes. I won't go to specify amount of time.
You know, the first thing, Adam, right? As a plumber, right? The first thing is you got to turn the stopcock off.
Yeah.
Doesn't work.
Snaps off.
It snaps off in your hands.
Yeah.
It doesn't work. So you're outside in the road. You turn off the road, undoing that stopcock, rewash it. And so it goes on. Then you want to drain the system down. You can't drain the system down. The bloody thing's clogged up. You know. So honestly, it goes on.
I
cylinders.
Hot
water cylinders.
well.
Draining hot water cylinders down.
Take
the top connection out. Put the hose down. Go downstairs. Suck a lung full of water.
So it will, just going back to the water tank, will it have an immersion heater on it for backup if you need?
The water tank will do,
Two,
exactly
I should imagine.
that. It's got one specified. If you wanted two, we could definitely specify two, but it's got one.
At the moment.
Normally the taller ones do have two in. Because these are the ones designed by us, we've only thought to put one in. But
don't forget we got the solar energy pushing one, and then the other.
Well, this is another bit of work I'd like to do with you, because you're always better off multiplying your solar energy through a heat pump, and then you'll end up exporting more and getting paid for more exported energy.
Rather than heating the water.
Yeah, because it's why use 100% efficiency when we can multiply it by 4 or up to 5 maybe. So there's a few things with there, but then we start with, potentially getting to automation. There's a few other things. So let's get the basic simple thing down. We can wire it into the immersion for now, and then we'll take what the next step is.
In the summer, you might want to not have the heat pump on at all, and therefore the direct electricity input from the solar panels, I would have thought was quite beneficial.
That is a good point.
The reason why it's better to heat via the heat pump in the summer is because the outside air temperature is so high.
So you're getting 7 cop, maybe. You
exactly.
don't know.
Well, up to that, so it's even more savings.
Yeah.
Do you know what? If we want to trick this and make your cop look super efficient, actually we would feed the immersion via the solar PV directly, because hot water is less efficient than heating. The summer actually drags down the average SCOP slightly, so we could trick your system. I know how to fudge around the SCOPs, but we're not going to need to. You're going to have the most efficient system
because the flow rate through the cylinder isn't as much as it is through the heating circuit.
It needs a higher flow temperature for the hot water as it does for the radiators. So what you have is your summer months look slightly less efficient on average. I've got a graph for this actually, and then your shoulder months, spring and autumn, they're highest, and then December, January, February dip again. I'll show you on my phone my system. By trimming off anything in the summer and turning it off in the summer, you can make the SCOPs look more efficient. But if you included the efficiency of your immersion, your SCOP would tank right down, because actually you're just wasting energy in there because it's only 100% efficient, which is obviously a strange thing to say. Oh, there's mine at the top of the charts at the mind.
So you could get mine up sort of vying with yours. This is
top of the
SCOPs, because I'm going to be involved. If I wasn't here putting it in, I would be very angry if you got above me. But
we could have a bit of a bet on all of this.
When people at parties start showing you pictures of their kids and all the rest of it, do you do that with the just have a look at my cop, my SCOP?
A picture in my wallet. I mean, this is the evidence of that they work really at all. You can see there, I'll show you in a second, Roger. That's summer. This is average SCOP. So the average SCOP doesn't drop below 4. It drops in summer because it's mainly hot water, and then much more heating here. However, the heating here, efficiency here drops back down again. The average efficiency of mine in the last 30 days is 4.7.
So what's the, you're showing my
average overall is 4.9.
Difference between SCOP and COP?
COP is efficiency at any one point in time, or like a day. SCOP accounts for the whole year.
Oh, I see. Right.
So you're going to get a better one because it's got the summer in it.
Yeah. So this is the summer, because it's doing more hot water as a percentage. This is SCOP. The lowest it goes down to is 3.4 or something. The highest is about 5.1. In the summer, there's more hot water, so the average SCOP's lower. And in the spring here, so in autumn here, it's the highest kind of average efficiency, because we've got nice low flow temperatures to our radiators, and then we need hotter flow temperature to our radiators, which brings back down the SCOP, and you basically get this kind of ribbon effect. Yeah, that's how all kind of efficient systems work. If we just get rid of this section here by only heating via the PV directly to the immersion, our average will look higher because it's not dragged down by those months. Yeah, I mean, any sort of questions?
I suppose the only thing at the moment is the physical positioning of the heat pump and whether it narrows the side entrance.
Let's go through that when we go outside. We can take another picture and you can literally see it in situ. So rather than measuring it, you've got a augmented reality. You can see what it will physically look like.
Okay.
So the proposal is the heat pump gets changed, even though a lot of people on the video have said you don't need to change it, just renew the bearings on the fan. And I did look, actually, it's about 15 quid, those bearings, so we'll probably get that up and running.
Yes.
To see how that goes, if that's where the noise is coming from.
You can do that, but if the target is to have the heat pump cost less than a gas boiler, I don't think that heat pump's going to cost less than a gas boiler. I've done some research since, and the lowest flow temperature from that high temperature heat pump is 45 degrees. Okay. So it's set to its lowest temperature. You need to be able to go lower than that to have weather compensation.
Okay, so that one's going, and so that'll be on the market. Anybody who's interested in buying, let us know.
Absolutely.
So that will go. The buffer tank will go.
Buffer tank, I'm probably going to suggest to stay. I need to do a couple of calculations. There's a few reasons for that. I've noticed there's a lot of plastic pipework in your house, which has the inserts which restrict the flow, and this heat pump comes with an internal pump. So we can't select a specific pump for your house. Oh, you're not going to leave that big
pump there then?
We might reuse that pump.
Because that's a biggie, isn't it?
I might reuse that. I think that's set a bit too low, that pump, actually. Just touching some of your radiators, that temperature drop was too wide. So I may reuse that or might get you a new one because I don't really want faults coming back after we've upgraded it. So I'm probably going to suggest to put a buffer in here. I'd say we put a buffer in 15% of jobs, not even that, maybe 5% of jobs in fact. But this is a bigger house, it's got plastic pipework, this needs a buffer, which is a shame because it means our scope's going to be a tiny bit lower.
Okay.
Do you think we should risk without it?
Well, no. I don't take risks generally. If I had a buffer, I'd bypass it, with a couple of valves to bypass it if,
I think we should do that. Yeah, I think that's a good idea.
Then you can bring the buffer in if you want, and if it's working without it, don't worry. But the thing I'm concerned about is the antifreeze side of it, because you're not going to put any glycol in it.
You're not going to put any glycol.
So you're going to put any kind of drain down on it, or what's going to happen there?
We're going to put a antifreeze valve outside, which opens up if it gets too cold. We're doing that because the manufacturer recommends that we fit glycol or one of those. Some manufacturers
just dump the water out of the heat pump side of it, not from the hole in the radiators and everything. Yeah.
Well, it depends on how you put it together.
You don't want it to drain down your whole system, do you?
No, it'll just let go of that bit outside. You'll get a bit maybe come out the house.
Yeah. And then you have to repressurize it afterwards.
Exactly. Okay. I mean, when was the last time you had a power cut?
Oh, I can't remember.
And then
last time went was when that
when the heat pump
thing went.
I meant a local one.
It was that modulator thing that is on the wall there. Failed, and the electrician bypassed it.
How long was the power cut for?
24 hours, 12 hours. Okay. 12 hours perhaps.
If you're going to have regular incidents like that, definitely fit an antifreeze valve. AFV.
Normally you don't get that power cut.
Yeah, normally people get like brownouts or whatever, where it flickers off or goes off for 10 minutes. You're not going to freeze your pipes for within 10 minutes. No. The whole point is these work on weather compensation, so they're already running hotter than they ever would need to when it's minus anyway. Yeah. So the chances of it freezing up are almost zero. They don't fit them in places like Sweden at all. They just run them directly. So I think it was just something that's been left in, literature and regs again of old. We're fitting one anyway to comply with manufacturers. This is just kind of like a side subject.
You've got to do that because if you ignore the manufacturer's recommendations on anything, they can run a mile from any kind of warranty.
If that was the case and we put it in and we were the ones that went against the warranty, we're the warranty anyway for you. So that's why we're guaranteeing it. The performance guarantee is that it works, obviously, and that you're comfortable and that it's efficient. I mean, any other sort of questions?
No.
We should do. I want to get this thing submitted and then do a Zoom call with you and show you. It's a real shame that I can't show you. I'm going to try it one more time. A real shame that I can't show you this because A, it's snazzy and cool, but B, it really gives you an idea of a little bit of insulation can have a much bigger impact on your overall efficiency. You might halve your heat loss. But you'll save more than half of your bills because the efficiency's gone up.
Well, we're all fans of insulation, but we're not fans of blocking up the Dartford crossing for 3 days just to make the point. And this is the bit where Adam says You do need a buffer tank on some occasions.
Well, I've said that on every single video.
No, you didn't.
Well,
because on the first video we did, and you were critiquing it and sitting there with Patrick going, "You don't need a buffer tank."
You don't need a buffer tank on all installations. You only need them on some fringe cases. If I do say that, please, Roger, put it in the video now. All right.
Listen, I don't care, mate. People go, it's not about winning. It's about, in the end, getting something that works. And that's that. And I don't care who's come up with the idea or who does it. But I just think that John's experience from all the countless emails and comments we get, John's experience is not unique. There's a lot of people out there who are saying the worst thing I ever did. There was a guy the other day, he said he's had it for 8 years or something. It's never worked, it's been a constant problem, cost him a load of money. He's now going back to gas, but he still owes 10,000 quid on the installation.
Oh, God.
Because it was one of those where he was supposed to be paying it off from the savings made on the fuel bills. That was a green deal, wasn't it?
That's it. Yeah.
And it never happened. So he hasn't paid it off, but it doesn't mean he hasn't got to pay it off.
Yeah, I mean, you're totally right, but the reality is that there's thousands of people potentially out there that have been the victim of a bad install, not heat pumps.
Yeah.
Heat pumps work. It just needs to be guaranteed.
Yeah.
Which we have hundreds of them out there now.
But it is complex.
Yeah, it is.
Heating is complex.
Yeah, it's an engineering job.
Yeah.
And this is why heating engineers deserve the respect they deserve.
It's kind of complicated but simple, because what you said the other day, you said we're talking about a box on the outside which is pumping warm water in. Everything else is on the inside, and it's all about flow rates. And so it's actually about keeping the system as open as you can, not zoning it, not doing any manifolds, anything like that, just keeping all the water rushing through as fast as you can.
Yeah, people will naturally, and rightfully so, say, but I want some rooms off because I'm only working in this half of the house, etc. That makes sense, and it does logically make sense, something you're going to lose less heat by not heating some rooms. But that's made up for, and then some, by heating up those rooms, because your efficiency increases by so much, your overall bill comes down.
Yeah.
And that's the trick, that's the psychological trick.
It's less comfortable as well, isn't it, when you've got
cold rooms in.
The other thing is, sorry John, do you want to...
No, I was going to say, one of the things that strikes me about all of this is the difference between the guy on the tools connecting pipes together and the guy designing the system. Surely that's a huge...
Well, I would say that every heat pump I've installed, apart from the swimming pool ones actually, but all the other ones I've done to a drawing. Somebody else has given me the drawing. So when people say, well, the reason it's not working is because you're an idiot, mate, you don't know what you're doing, I'm going, well, hang on, all I'm doing is connecting up the pipes. If they tell me I want 22 pipe and 15 there, that's what I do. Don't come back to me. But they always come back to you. You're the installer. You're to blame.
That is the trick that's ended us up where we are. Someone designing a system in Manchester for a system in Southampton that they've never seen or can see. Someone gets a drawing, and then if it's specifically a retrofit and they lift the floorboards, it's the wrong size pipe. If they've not understood why, they're not going to be able to implement that design. So the whole point and the whole thing behind Heat Geek is we need to train installer, not have a separate designer. The installer needs to, he can basically kind of make it up on site if he understands the underlying theory. And this is why the installer has to be put on this pedestal, I believe, as the main person behind making these things successful. Having someone separate who's never even been to the property is a red herring people have wasted thousands on and been trapped by. In fact, most installations, I'd say, that are poor have that set up where the guy who's on site isn't the system designer. It's that disconnect that's the cause of most of these problems.
I hate to ask this question, right? But as someone looking from the outside in, this is quite academic, a lot of this stuff. Are heating engineers capable of doing it? Have we got the education behind it? We have the raw material.
We didn't have the education. It's actually not that complicated. It's very basic. But Tom's a perfect example.
It's actually doing it well or right is actually easier. Is what I found.
All right.
I was someone who was throwing things in, randomly here, there, and everywhere. Correct size here and there. Now is what I'm trying to do, and it is actually become a lot easier. So once it's all put in, then turning it on and giving you comfort as a customer is far simpler. Messing about with these old houses where things have been put in the wrong size and whatnot, trying to balance it all is is actually really hard.
I just wondered if the education system was producing people with the right basic.
No, it's not,
maths and all the rest.
which is why we had to create our own training specifically for that. Tom is one of 2,000 people that we've now trained, and anyone that's taken our training knows how to design these systems and install them. With the heat pumps to be successful, the installer has to have 95% of what he has to have is knowing how to connect pipes together, knowing how to check for leaks, understanding the different types of systems in different aged houses. The last 5% is a theory bit, which we teach online, which just unlocks this whole other world. Most of the stuff they need to know, they have to learn on site in real situations. You can't really learn it in a classroom where you've got one bay that doesn't replicate all the other types of systems in the country.
It's a lot of calculations though, a lot of maths it seems to me.
It is. It's good to understand them, but you know, with apps and things like that now, I believe it's doable. I think we're doing it.
When I was on that Jeremy Vine show arguing with the heat pump guy he said, I can install a heat pump. My guys will install a heat pump in 2 days flat to the existing system and it will work, you know. And
that's
I said, I'd like to see that. I'd like you to, you know. And he did say he'd come round and install one in my house free of charge because I never heard from him again. But
I think that video is the most objectionable one I'd heard about heat pumps from the industry side, quite frankly.
Yeah.
Because having experienced it over 5 years and listening to that guy, and I thought, well, he's done his PR, he's good at PR.
I don't think he was good at PR because he just seemed to me like he was desperate to get in there and get the grant money for anything that was going, and that he would whack you in a heat pump, be gone in 2 days, which every householder wants to hear. How long is it going to take? 2 days. But actually, the reality is, as I just described, with draining down a cylinder, turning off a stopcock, putting in an electricity supply, 2 days.
It was partly as a result of that video that I contacted you in the first place. So I was so annoyed about it because it's not that simple. You made it sound simple.
It's not that simple at all.
It's clearly, even from a layman's point of view, it's clearly not.
It's a heat pump installation is around 15 man days. So it could be 5 days if you've got 3 of you on, and that's you're hoping nothing goes wrong and, all that kind of thing. So, no, I mean, if you're bashing them in, yeah, maybe, but you're going to be spending a lot more than you did on your gas. That's the whole point. It needs the time, care and attention. If you're trying to make it as similar to a boiler installation, well, then you can't have it both. You can't have the efficiency and have the time. You have to sacrifice one or the other. Like I said last time I was here, this is relatively new to this country, this industry, and it's just growing pains. The solutions are there now, though, in small pockets. Some companies know what they're doing. Other companies less so, and we're waiting to iron out essentially who's who. Some companies will thrive because they know what they're doing, and some won't.
Yeah, but the consumer shouldn't have to pay for it.
They shouldn't.
But that's what's been happening.
Yep, that's the idea of the bus grant, to enable more money to go through to iron out the stuff.
The more poor systems that are put in, the more the government's going to be under pressure to stop rolling out its policy.
Well, I think,
I spoke to my local MP and said, don't put a heat pump in. For all the reasons. And his wife said, we're not going to do that.
I think it goes further. I think I can see the day, and I don't think it's very far off, when the government is going to have to start compensating people because they're offering the grant. They're saying the MCS people are the installers. So that's got the tacit approval of the government. If they then put a heat pump in for you that doesn't work and you've taken out your gas boiler on the promise of, the government's contract is you take your gas boiler out, put in the heat pump, all your troubles are over. If it's not, and you say, I can't heat my house with this thing, it's costing me a fortune to run, then to my mind, that's mis-selling. And at some point, I think the government is going to have to say, have you been mis-sold a heat pump, and start compensating. And honestly, I think it's terrible that that's going to happen, but I think it will happen because it only takes one person to push it, because at the moment it's illegal to go backwards. You can't install a gas boiler after having had a heat pump, in theory, because...
So the government doesn't like paying out. We know that from...
Well, it doesn't, but look how many times it has. Look how many times it's been pressured into compensation for this, that and the other.
And you can't get the industry to do it because the industry, they tend to go bust these.
No, definitely not. That's what I'm saying. I think it'll be down, another one where they just expect the government to pick up all the taxpayer.
We've got to make it better, haven't we?
Exactly.
We're making it better, so then the
you are.
And there's a competition as well, isn't it?
Absolutely, but at some point the consumer needs some kind of reassurance that it's going to heat the house and it's going to be at least affordable,
This is why I don't think the government should be. I think it should be down to the business to have the reputation to say we guarantee this efficiency, and perhaps you don't even have to pay for the job until it proves that it is that
want
efficient.
to go back. I mean, what makes a really good company for me is when a customer tells me I've got something wrong, I go back. When the customer doesn't tell me, that's what really annoys me. So actually, I agree. Having the business, being the one that's.
Yeah.
Well, I think
it's
small
quite amusing.
businesses.
I like that because I've had people say, plumbers go, I've stuck in hundreds of showers and I've never had a problem. Oh, really? You mean they've never called you back? The thing's been leaking after the second week and they haven't called you back because they just thought, we get somebody who knows what they're doing.
You mentioned you were offered a free heat pump. Would you have a free heat pump if you were offered a free heat pump?
Well, I personally, no. Personally, no. But that isn't to say I wouldn't give it a go. I think, again, I've got a wife who would say, oh, no, really, do we want to go? Because she doesn't like heat, weirdly enough. I mean, she hates hot bedrooms. We sleep with two windows. We've got a cross flow. Windows on two aspects. She has one open there, and the curtains blow like mad. And honestly,
if she likes the house cold, I could give her a really efficient heat pump.
Yeah, it's close. It's close to some nights. It's close to freezing point in our bedroom. Wow. But that's the way she wants it. That's why she won't sleep in a room that's slightly a bit warm. So for her, she likes a warm room in the evening, watching TV, and that's it.
We have a cold earth bedroom.
There's a way to do that with balancing. There's ways to do that.
Yeah.
I'll put her out in the garden shed personally, but
But most of the time we've got the radiator off in our bedroom, and we just realise
we've never had it on. I put it in just in case somebody, we sold the house or whatever, but it's never been used.
Then we go from sort of 16, 14 degrees into a bathroom was 22 or something.
Yeah. This will be something that I'll have to sort of kind of show you, and you have to learn how to get the most out of the system. You can make it run however you want. But if you want maximum efficiency, and if you're thinking about saving more money, the ways to do that are minimise the differential between nighttime and daytime, and I like to come down in the daytime as well as up in the nighttime if you want to, and minimise the differential between rooms. You can do it, but you will pay for it in running costs. That's the trade-off. That's the basic trade-off.